And the seismic waves still slow down under Yellowstone today, showing that the magma chamber still lurks under the park. It's more than 30 miles long, 25 miles wide, and 10 miles in depth. But its size alters from year to year as it fills or empties with semi-liquid rock at an incredible 1,500 degrees Fahrenheit. This is the hidden beating heart of Yellowstone Park. The way it moves deforms the ground above, explaining the fault lines and the earthquakes they produce. And its heat ultimately powers all of Yellowstone's hot water pools and geysers. Subterranean Yellowstone is giving up its secrets. Seismographs record thousands of earthquakes in the park. And the evidence of earthquake waves reveals a massive magma chamber miles under Yellowstone's surface. But the Yellowstone investigation is far from finished, because there's evidence of another, even more monstrous-sized structure under the park. By the beginning of the 21st century, scientists investigating how Yellowstone was made had images of what lay under the park. But there was a problem. Technology only allowed a view of a few miles below the surface. Then, as more and more data was fed into more and more powerful computers, there was a breakthrough. In April 2006, geologists published new diagrams of hot structures far deeper under the park, and computers painted more detailed pictures. The results were startling. Investigators saw for the first time the sleeping monster that lies below Yellowstone Park. Snaking down hundreds of miles into the earth, far deeper than the relatively shallow magma chamber, is a colossal volcanic pipe. Nobody's certain how deep it goes, but they can picture it down to 400 miles or more, twice the distance between Washington and New York. Smith makes an educated guess about what the underground plume is like.
Our best estimates now, as we start doing the physics and the dynamics of these things, it's like a conduit of melted rock, like a chimney.
That chimney, called a hotspot, pumped up enough heat to melt the rocks of the crust and fill the overlying magma chamber, which then erupted to blast out Yellowstone's vast crater. Understanding how the crater formed was an important moment for the investigation, because there was evidence that similar eruptions had happened before, many times before. Throughout the 1960s, various teams of geologists studied the Snake River Plain to the southwest of Yellowstone Park and found traces of ancient volcanic craters. The crater rims had long been eroded, but their outlines were confirmed by aerial pictures over the following decade. They ran in a straight line along the plain, heading for the heart of Yellowstone Park. On average, each crater was a couple of million years older than its neighbor. Investigators realized that these are the remnants of earlier supervolcano explosions, an unbroken chain stretching far back into geological history. It seemed clear that time after time, the hotspot had blasted out a super eruption and then moved on. The hotspot appeared to have traveled hundreds of miles. But that posed yet another riddle. How could a hotspot, anchored to the core of the planet, be moving? important clue had been found in 1985 by American volcanologist William Scott. He realized that plotting the location of 30,000 earthquakes around Yellowstone produced an amazing pattern. The quakes traced out a giant V-shape on the surface of the Earth. The V-shape wrapped around the hotspot's location. It seemed at first to confirm that the hotspot was still moving, rippling up the land around it with fault lines and tens of thousands of earthquakes. But the real answer lay with the theory of plate tectonics. It showed that it's the American continent, not the hotspot, that's moving. And the chain of craters on Snake River Plain is there because for millions of years, the moving American continent has continually pushed new land over the stationary hotspot.
But as the North American plate moved across this source of heat, it pops through the lid and creates the hotspot track. That's the Snake River Plain. Yellowstone is just the active component today.
The repeated hotspot explosions on land have made Yellowstone unique. Other hotspots have been identified around the world, like the one that has created the island chain of Hawaii. But Yellowstone is the only place where a hotspot has erupted in the middle of a continent. Each of the earlier explosions blew the original mountains to pieces. Then the land smoothed over with later flows of more runny lava that was released from deep under the Earth's crust. Multiple strands of evidence combined to reveal Yellowstone's slumbering monster, the gigantic hotspot plume lying under the park. Earthquake maps show the hotspot's location. Seismic waves reveal the depth of the plume. And earlier craters prove regular super eruptions over millions of years. All of which leads to the most frightening question of all. When will Yellowstone erupt again? Measuring the amount and geographical spread of ashfall from Yellowstone super eruptions produced some terrifying figures. 640,000 years ago, the eruption poured out around 240 cubic miles of material. Enough to bury the whole of New York State tens of feet deep in ash. If it happens again, thousands will die. Vast areas of the United States will be buried in volcanic debris. But when will Yellowstone erupt again? One clue to when that next eruption will happen comes from investigating the eruptions of the past. The hotspot punches out a super eruption on average every 600,000 years. And the last one was 640,000 years ago. But geologists expect that there will be warning signs before Yellowstone explodes again. Volcanic eruptions are usually preceded by an increasing number of earthquakes.